There is a loaf of bread sitting somewhere in your kitchen right now. Maybe it's in a plastic bag on the counter. Maybe it's in the refrigerator. Maybe you've been buying the same brand for years because the label says things like whole wheat, whole grain, high fiber, or heart healthy. You probably believe you're making a better choice. Millions of Americans do. Every year, Americans purchase billions of dollars worth of whole wheat bread because they think it is healthier than white bread. And in many cases, they're right. But here's the strange part. Not every loaf called whole wheat bread is what people think it is. Some contain added sugars. Some contain dough conditioners. Some contain preservatives designed to keep bread soft for weeks. And some breads that look dark brown get part of their color from ingredients like molasses or caramel coloring rather than the grain itself. The loaf that appears healthier isn't always the loaf with the most whole grain, but the biggest surprise isn't what's added, it's what gets removed. Because long before that loaf reached the supermarket shelf, long before it was sliced and sealed inside plastic, the wheat itself passed through a series of industrial processes that dramatically changed how it behaves. The bread may still contain the bran. It may still contain the germ. It may still legally qualify as whole wheat, but the grain that entered the factory is no longer the grain that came out. And that's where the story begins. Because whole wheat bread wasn't invented as a health food. In fact, for much of modern history, Americans preferred white bread. White bread was cleaner, whiter, softer, more expensive. And for decades, whole grain bread was considered food for poor families who couldn't afford refined flour. Then everything flipped. Scientists began studying fiber. Nutrition experts started linking whole grains to health benefits. Consumers became suspicious of highly refined foods. And suddenly the bread once viewed as inferior became a premium product. Today, whole wheat bread is one of the largest categories in the American bakery industry. Factories produce millions of loaves every single day. Automated systems mix ferment shape, bake slice, and package bread with extraordinary precision. Yet hidden inside this familiar product is a story that involves ancient agriculture, modern food science, industrial engineering, nutrition, marketing, and one simple question. What exactly makes whole wheat bread different? To answer that question, we have to go back to the beginning. Not to the bakery, not to the factory, but to a wheat field stretching across the American Midwest. Because everything starts with a tiny grain most people never look at closely. And that tiny grain determines everything that happens next. The journey of whole wheat bread begins thousands of kilometers away from the supermarket. It starts in vast wheat fields stretching across Kansas, North Dakota, Montana, and other regions known as America's breadbasket. From the air, these farms look endless. Golden waves moving with the wind, millions of wheat plants standing shoulder to shoulder beneath the summer sun. Yet every loaf of whole wheat bread depends on a structure so small that most people never notice it. A single wheat kernel. At first glance, it looks simple, but inside that tiny grain are three distinct parts: the bran, the germ, and the endosperm. The bran forms the outer shell. It contains most of the fiber. The germ is the living embryo of the seed. It contains oils, vitamins, minerals, and nutrients that help a new wheat plant grow. The endosperm makes up the largest portion of the grain. It consists primarily of starch and protein. When most people imagine wheat, they picture one ingredient. In reality, every kernel is a natural package containing three completely different materials. And for more than a century, the flour industry was designed to separate them. Harvest season usually begins when wheat moisture falls below approximately 14%. If harvested too early, excess moisture can lead to mold growth during storage. Too late and strong winds or storms can damage the crop. Modern combines move through fields like giant factories on wheels. As the machines advance, rotating headers cut the wheat stalks. Inside, the combine threshing drums separate kernels from stems and husks. Powerful fans remove lightweight debris. What remains are clean wheat kernels flowing into storage tanks. A modern combine can harvest enough wheat in a single day to produce tens of thousands of loaves of bread. But harvesting is only the beginning. The wheat is transported to grain elevators. These towering storage facilities dominate the skylines of many farming towns. Some hold hundreds of thousands of tons of grain. Here, every load undergoes inspection. Technicians test moisture levels, protein content, foreign material, kernel damage. Even slight differences matter, because not all wheat behaves the same way inside a bakery. Higher protein wheat creates stronger gluten networks. Lower protein wheat produces softer baked goods. Whole wheat bread manufacturers often blend multiple wheat varieties to achieve consistency. Consumers expect every loaf to look and taste identical. Nature rarely cooperates. The mill must compensate. After storage, the wheat enters one of the most important facilities in the entire process, the flour mill. This is where the story takes an unexpected turn, because for over 100 years, flour mills were designed to remove the very parts that modern consumers now want to keep. When wheat enters the mill, it first passes through cleaning systems. Screens remove stones, magnets capture metal fragments, air currents remove dust and chaff. Sophisticated optical sorters inspect individual kernels at incredible speed. Defective grains are rejected automatically. Only then does milling begin. In traditional white flour production, large steel roller mills gradually break apart the kernel. The bran is removed. The germ is removed. Only the starchy endosperm remains. The result is the bright white flour that dominated American kitchens for generations. White flour had advantages. It produced softer bread, lighter texture, longer shelf life, and perhaps most importantly, it was easier to store. Because the germ contains oils, and oils eventually become rancid, millers saw the germ as a problem. Consumers saw white bread as a luxury. Everybody seemed happy. Then nutritional science changed the conversation. Researchers began examining the nutrients lost during refining: fiber, minerals, certain vitamins. The parts removed during milling suddenly became valuable again. And that created a challenge. How do you make whole wheat flour on an industrial scale? The answer sounds simple. Keep all three parts of the grain. But doing that consistently inside a modern factory is far more complicated than most people realize. Because bran behaves differently than starch, germ behaves differently than bran, and all three components affect baking in different ways. The mill must grind the entire kernel while maintaining the proper balance. Too much coarse bran and the bread becomes dense. Too little and it loses its whole grain character. The goal is precision. The entire wheat kernel is ground into flour, nothing removed, nothing discarded, everything retained, at least in theory. But here's what nobody tells you. The moment the grain is crushed, a clock starts ticking. Because the germ that makes whole wheat flour nutritious also makes it unstable. The natural oils exposed during grinding begin reacting with oxygen, slowly, silently. And that challenge would eventually force bread manufacturers to completely rethink how whole wheat bread is made. The wheat may still be whole, but keeping it fresh is an entirely different battle. And that battle begins the moment the flour leaves the mill. Once the whole wheat flour leaves the mill, it travels to bakeries capable of producing hundreds of thousands of loaves every day. From the outside, these facilities look more like manufacturing plants than traditional bakeries. There are no wooden tables, no bakers kneading dough by hand, no warm village ovens. Instead, there are stainless steel silos, automated mixers, computerized fermentation systems, conveyor belts, stretching hundreds of meters, and ovens large enough to swallow entire trucks. This is where whole wheat bread becomes an industrial product. And this is where one of the biggest challenges begins, because whole wheat flour does not behave like white flour. The bran particles that make whole wheat nutritious also interfere with gluten development. Think of gluten as a network of elastic strands. When dough rises, those strands trap carbon dioxide produced by yeast. The stronger the network, the more volume the bread develops. But bran acts like tiny blades. As the dough mixes, the sharp particles cut through portions of the gluten structure. The result is denser bread. Heavier texture, less rise. For decades, consumers associated soft bread with quality. And that created a problem. People wanted whole wheat nutrition, but they still wanted white bread softness. The factory had to find a way to deliver both. Everything begins in giant mixing systems. Flour arrives through pneumatic tubes connected directly to storage silos. Computer-controlled dispensers measure exact quantities. Nothing is estimated. Every ingredient is weighed to the gram. Whole wheat flour enters first, then water, yeast, salt, sometimes sugar, sometimes honey, sometimes molasses, depending on the brand. Large commercial mixers hold thousands of kilograms of dough at once. Massive spiral hooks rotate through the mixture. At first it resembles wet sand. Then a rough mass forms. Gradually the dough becomes smoother, more elastic, more uniform. The mixing stage typically lasts between 8 and 15 minutes. But the real science happens inside the dough itself. Water activates proteins. Gluten begins forming, yeast wakes up. Enzymes start breaking starch into simple sugars. A chain reaction has begun. And every loaf in the factory now depends on millions of living microorganisms. Yeast. Most people think yeast's job is simple: make bread rise. but the process is far more remarkable. Each yeast cell consumes sugars and releases carbon dioxide. Those gas bubbles become trapped inside the gluten network. The dough slowly expands. At the same time, yeast produces hundreds of flavor compounds. Alcohols, organic acids, esters, molecules that contribute to the aroma people associate with fresh bread. Without fermentation, bread would taste surprisingly bland. The dough now enters fermentation chambers. Temperature and humidity are carefully controlled. Too cold and yeast becomes sluggish. Too warm and fermentation becomes unpredictable. Most facilities maintain temperatures between 80 and 95 degrees Fahrenheit. Inside these chambers, the dough rests, expands, develops flavor, builds structure. For some artisan breads, fermentation may last many hours, even days. Industrial bakeries don't have that luxury. They must balance flavor with production speed. Every minute costs money. Every delay affects thousands of loaves. So engineers carefully optimize the process. Fast enough for efficiency, long enough for quality. After fermentation, the dough moves to dividing machines. This is where individual loaves begin to take shape. Automated cutters portion the dough into identical pieces. Every piece must weigh exactly the same. Too heavy and packaging specifications fail. Too light and customers receive less product than advertised. Precision matters. The portions move through rounders, machines that gently shape the dough into smooth balls. The dough then enters intermediate proofers where it rests briefly. This relaxation period allows the gluten network to recover from handling. Without it, shaping would become difficult. Next comes molding. Rollers flatten the dough, then curl it into cylinders. Each cylinder becomes the familiar loaf shape consumers recognize instantly. Rows of dough enter metal baking pans, perfectly aligned, perfectly measured, ready for one final rise. This stage is called proofing, and it may be the most important part of the entire process, because this is where the loaf reaches nearly its final size. Inside giant proofing chambers, warm, humid air surrounds the dough. The yeast becomes increasingly active. Carbon dioxide production accelerates. The dough swells upward. What entered as a dense mass now begins resembling bread. Then the pans reach the ovens, and everything changes. The moment the dough enters temperatures above 140 degrees Fahrenheit, yeast activity surges briefly. Bakers call this oven spring. The loaf experiences one final burst of expansion. For a few minutes it grows rapidly, then the yeast dies. Forever. But by then its work is complete. The structure has been formed. The bread enters baking tunnels that may exceed 100 feet in length. Temperatures often range from 375 to 450 degrees Fahrenheit. As the loaf travels through the oven, several transformations occur simultaneously. Moisture evaporates, starches gelatinize, proteins solidify, sugars caramelize. The crust develops color, and hundreds of new flavor compounds emerge. This is where the familiar smell of fresh bread is born. Not from the wheat, not from the yeast, but from thousands of chemical reactions occurring inside the oven. The aroma filling a bakery is essentially chemistry in the air. When the loaves emerge, they are fully baked, but they are far from finished. In fact, slicing them immediately would destroy them. Because inside every loaf, heat continues moving toward the center. Steam remains trapped. Moisture is still redistributing. The bread must cool. And that's where another hidden challenge appears. One that helps explain why modern whole wheat bread can remain soft for weeks. A challenge involving moisture mold and shelf life. Because the loaf leaving the oven is alive in a way most people never realize. And keeping it fresh is one of the biggest engineering problems in the bread industry. The loaf coming out of the oven looks finished, golden brown, soft, perfectly risen. Exactly what consumers expect. But here's the thing nobody tells you. The moment bread leaves the oven, it starts going stale. Not tomorrow, not next week, immediately. The process begins within hours, and it has almost nothing to do with the bread drying out. Most people think stale bread is simply bread that lost moisture. That's only part of the story. The real culprit is starch. Inside every loaf are billions of microscopic starch molecules that changed during baking. When dough entered the oven, heat and water caused these starches to swell and loosen. This transformation gave fresh bread its soft texture. But after cooling, those molecules begin reorganizing themselves. Slowly, relentlessly. Scientists call the process retrogradation. Consumers call it staleness. The bread becomes firmer, less elastic, less enjoyable. Even if moisture remains inside the loaf. This creates a major problem for manufacturers because consumers love fresh bread. But supermarkets need products that survive transportation, storage, warehouse distribution, shelf display, and several days in a kitchen. A loaf may travel hundreds or even thousands of miles before reaching a customer, and every hour increases the risk of staleness. That's where modern food science enters the story. Many whole wheat breads contain ingredients that most consumers never think about, not because they're dangerous, but because they perform jobs nobody sees. Dough conditioners, emulsifiers, enzymes, shelf life extenders, ingredients measured in fractions of a percent, yet capable of influencing an entire loaf. Some emulsifiers interact with starch molecules. They slow down retrogradation. The bread stays softer longer. Certain enzymes continue working even after mixing. They modify starch structures, improve texture, increase loaf volume, extend freshness. In many cases, these ingredients allow whole wheat bread to remain soft for over a week, sometimes much longer. Without them, many commercial loaves would become noticeably firmer after only a few days. But softness isn't the industry's biggest enemy. Mold is, because whole wheat bread contains moisture. And wherever moisture exists, microorganisms are interested. Mold spores are everywhere, floating through the air, settling on surfaces, waiting. A single spore landing on bread can eventually produce thousands of visible colonies. The familiar blue, green, or white patches that send a loaf directly to the trash. Factories fight this battle constantly. After baking, loaves move through long cooling conveyors. Powerful ventilation systems reduce temperature carefully. The goal isn't just cooling, it's controlling condensation. If warm bread enters packaging too quickly, trapped moisture creates ideal conditions for mold growth. The loaf may look perfect, but its shelf life collapses. Once cooled, industrial slicers move into action. Rows of razor-sharp blades cut each loaf into uniform slices within seconds. A machine can slice thousands of loaves every hour, far faster than any human bakery. The sliced bread then enters packaging systems. Plastic bags are sealed. Date codes are printed. The product is prepared for distribution. But here's where the story becomes interesting. Consumers often associate long shelf life with preservatives. And sometimes they're right. Certain breads contain preservatives specifically designed to slow mold growth. Calcium propionate is one of the most common. It has been used in commercial baking for decades. Without compounds like these, many packaged breads would spoil far more quickly, especially during warm weather, especially during long transportation cycles. Yet there's another side to the story, because not all shelf life comes from preservatives. Some comes from engineering. Factories carefully control moisture levels, cooling rates, packaging materials, airflow, even the thickness of the plastic bag matters. Every decision affects how long the loaf remains fresh. But now comes the biggest surprise. The thing many consumers believe makes whole wheat bread healthier may also create some of its biggest manufacturing challenges. Remember the wheat germ. The part of the grain rich in oils, vitamins, and nutrients. It contains natural fats. And fats eventually oxidize. When oxidation occurs, flavor changes. Freshness declines. Rancid notes can develop. This is one reason whole wheat flour traditionally had a shorter shelf life than white flour. The very component that improves nutrition also makes storage more complicated. For decades, this problem limited large-scale whole wheat production. Then technology improved. Modern milling, improved storage systems, better packaging, advanced supply chains all helped solve the problem. But another challenge emerged, one that had nothing to do with baking and everything to do with marketing, because consumers had started demanding healthier bread. And suddenly, every company wanted to sell it. The result was an explosion of labels: whole wheat, whole grain, multigrain, 12 grain, stone ground, ancient grain, honey wheat, made with whole grain. And that's where the real confusion begins, because some of those terms mean far more than others, and some mean far less than most people think. The loaf sitting in your kitchen may look healthy. The package may be covered with images of wheat fields, golden grain, farm fresh promises. But the truth isn't always on the front of the bag. It's hidden somewhere else entirely. And that's where the story takes its final turn. By the time whole wheat bread reaches a supermarket shelf, most of the hard work is already done. The wheat has been harvested, milled, mixed, fermented, baked, sliced, packaged. Yet for many consumers, the most important part of the story begins right here, standing in front of the bread aisle. looking at dozens of nearly identical loaves. Every package seems to promise something healthier. Whole grain, multigrain, 12 grain, ancient grain, stone ground, honey wheat, high fiber, made with whole grains. The shelves are filled with words that sound nutritious, but here's what nobody tells you. Not all of those terms mean the same thing. And some of them mean surprisingly little. Take multigrain. Many consumers assume multigrain automatically means healthier. It sounds impressive. Multiple grains must be better than one, right? Not necessarily. Multigrain simply means more than one grain was used. Those grains may be refined. They may not be whole grains at all. A multigrain loaf can legally contain mostly refined flour and still carry the label. Then there's made with whole grains. That phrase sounds reassuring, but it doesn't tell you how much whole grain is actually inside. A product containing a small percentage of whole grain can still use that wording. The phrase is technically true, yet it doesn't tell the entire story. The most important clue is often hidden in plain sight. The ingredient list. Ingredients are listed by weight. The first ingredient tells you more than most marketing slogans ever will. If the first ingredient is whole wheat flour, the product is primarily whole wheat. If enriched wheat flour appears first, the loaf is mostly refined flour regardless of the images printed on the package. The front of the bag sells the dream. The ingredient list tells the truth. And this isn't unique to bread. It's the same principle that revealed why Nutella contains more sugar than hazelnuts. It's the same principle that explains why garlic powder doesn't behave like fresh garlic. The label often tells the story, most people simply don't read it. Then there's color, perhaps the most misunderstood signal in the entire bread aisle. Consumers frequently associate darker bread with healthier bread. The darker the loaf, the more whole grain it must contain. At least that's what many people assume. But color can be deceptive. Molasses, brown sugar, caramel coloring. These ingredients can darken bread significantly. A darker loaf doesn't automatically contain more whole grain. Some breads achieve their appearance through grain content. Others achieve it through formulation. Two loaves sitting side by side may look nearly identical, yet one may contain substantially more whole wheat than the other. This confusion helped create one of the most successful marketing categories in modern food history. Because consumers weren't really buying bread, they were buying reassurance. The reassurance that they were making a healthier choice. And to be fair, whole wheat bread often is a healthier choice. Whole grains provide fiber, vitamins, minerals, plant compounds that are removed during refining. Numerous studies have linked higher whole grain consumption with better long-term health outcomes. That's why nutrition experts generally recommend whole grains over refined grains. But here's where the story becomes interesting. The healthiest loaf isn't always the one with the loudest marketing. Sometimes it's the one with the shortest ingredient list, the simplest formulation, the least amount of added sugar, the highest percentage of whole grain. The loaf that spends less effort advertising itself and more effort being what it claims to be. And that brings us back to the loaf sitting somewhere in your kitchen. The loaf you bought because it looked healthier. Maybe it is, maybe it isn't. The answer isn't on the front of the package. It's hidden in the ingredients because whole wheat bread isn't just bread. It's a product shaped by agriculture, food science, industrial engineering, nutrition research, and marketing. A tiny wheat kernel traveled through fields grain elevators, flour mills, industrial mixers, fermentation chambers, baking tunnels, slicing machines, packaging systems, distribution centers, and supermarket shelves before reaching your home. Millions of individual decisions influence that journey. Decisions about texture, flavor, shelf life, cost, nutrition, convenience. Every loaf represents a compromise between all of them, and that's the hidden truth. Whole wheat bread isn't healthier because it's brown. It isn't healthier because the package says multigrain, and it isn't healthier because of a picture of a wheat field printed on the label. What matters is what's actually inside. The grain, the ingredients, the formulation, the process. The loaf may still contain the bran, the germ, and the endosperm, the three parts of the grain that started this story. But now you know something most people never think about. That loaf is not simply the result of baking. It's the result of one of the most sophisticated food manufacturing systems ever created. A system designed to take one of humanity's oldest foods and transform it into a product that can travel across an entire country, remain soft for days, and still arrive on your table ready for breakfast. The package says whole wheat. The factory tells a much bigger story, and now every time you pick up a loaf, you'll know exactly where to look. That's the process. We reveal how things actually work one story at a time. If there's something you'd like us to explore next, let us know. Until then, trust the process,